So most of our work is already done. We have defined all the necessary methods for our CP dataset subclass of the dataset class. Now all that's left is a couple of technical things and seeing it in action. There are quite a lot of technical things, and that's the fun part of using code. You need to know all of the proper coding techniques, and then you also need to make them work with real data, and that's what this course is about. So I have all the functions that I already had, and I'm adding one new method called breakTrainValid, which breaks one of my datasets into two parts, one for training and one for validation. Okay, and this will be very useful when training deep learning models. And basically you can see that I'm breaking my list, the image list and the label list, into two parts according to a proportion that I'm giving to this method, to this break, train, and validation method. This will help me break down one big data set into two data sets. That will be something that will be useful for training deep learning models, but not today. Just one simple example to see that we can use our data sets with Python code. So I'm creating here a simple function to show a whole image that, and thus the moving of the axis that I did before. So this can be shown using matplotlib again. And then I'm creating a data set from my patches folder and printing how many. I'm breaking it into two using this method that I have just defined, and printing how many images I have in each of the two data sets that I have created, 1216 one and 839 in the other. And I'm also printing the number of classes, which was another of the methods that I had. Okay, I'm going to call the getItem method. I could call it by its name, but because it has a double underscore and it's because of that a magic method, it also gets called when I use the square bracket. So with this, I'm using a list comprehension over my data set to create a list of patches. Okay, this is very interesting, and I'm calling in every step of the list comprehension the getItem method. And finally, here I'm going to just select and show a few of my patches. I'm going to random. Oh, this is very interesting. Sometimes matplotlib just decides to show everything small. If you run it again, it will go back to being the proper size. And I'm showing 30 patches here, shuffling them randomly and plotting them in a figure with 100 times 100 patches in every position. And I'm showing all of my patches. Okay, nice exercise here would be to also show in the title of each patch the class it belongs to. Okay, because I have the label information in each patch whenever I call. This would also be quite easy to do. But basically my main message here was that I now have my image data in a dataset form that now PyTorch can interpret, and I can also use it, but mostly I will use it to just give it to PyTorch. So PyTorch can then optimize deep learning networks. PyTorch is, let's say, data agnostic. It doesn't know what the data it is optimizing, it is using to train deep learning networks are. It can be data from words. It knows that it's working with matrices, but these matrices might come from words, from embeddings made out of words, which is what people from the natural language processing, ChatGPT and all these guys do. Or they can correspond to images, like I'm doing here. In any case, I have to translate my images into some matrices that PyTorch can read, and so it can read them properly. I need to define a data set. that we have done here. So now we are ready to use in the last sessions of this course our data to train deep learning networks. This is all for today.